All right, guys, everybody have a note sheet and a graphing calculator. What we're looking at today, what we're talking about today is systems of non-linear, or solving non-linear systems by graphing and substitution. We'll look at elimination and graphing again, but solving non-linear systems. Now, we've done linear systems before. Linear systems is just we're looking at two equations of, or equation of two lines. And one of two things is going to happen. Either, well, one of three things. Either A, they're going to intersect at a point. There's going to be a single solution. B, the two lines are parallel to each other, so there is no solution. Or C, both equations are the same line, so there is infinitely many solutions. So we have one of these three, and especially we had these when we had systems of linear equations. And all that means is we have two equations of two lines, and we see where they intersect, where they cross, where they are both true. They have the same value. Now, nonlinear systems, specifically what we're going to look at, is we're going to have an equation of a line and a parabola. And one of the three things is going to happen. Either A, no solution. There is no point that the two graphs cross each other. So we have no solution, because again, we're looking for the point where they intersect, where they cross. And our second case is that there's one solution. They will intersect each other at a single point. Or B, there's two solutions. There's 2 points where they cross, where they intersect. And this one is unique to this here, because in lines, it's either going to be one, none, or infinitely many. Here we can actually have two. And with an equation of a line and a parabola, there's not going to be an infinitely many, because a line and a parabola are not the same shape, so they don't overlap. Now, first we're going to look at, in these first few here, we're going to solve the system of equation by graphing. So you will need your graphing calculator. And the first thing we're going to do with the graphing calculator is we'll turn it on. We'll need to turn the graphing calculator on and then hit y equals. Y equals. First thing we'll do is turn it on and then hit y equals. Everybody get to this point here. You might have equations typed in. We'll need to clear them out. We'll type the first equation in. So 2x squared plus 5x minus 1. Questions on how we type the first equation in so far? Now, once you get the first equation in, we'll type the second equation in also, x minus 3. X minus 3 is our equation of the line. Our 2x squared plus 5x minus 1 is our parabola. Are we able to get both of these typed in? And we're solving this by graphing, so we might need to graph. And we can see here that they do intersect. It might be a point, it might be 2 points, but they do intersect the graph. The two graphs do intersect. Now if we go second graph, yes sir. Hit y equals, or probably going to tell it to quit. Hit enter. Okay. They had plot 1 turned on, so it's trying to take information from plot 1 or for plot 1, and most likely there's no information there, so it's having an issue trying to plot something that's not there. Everybody able to get to this table, yes? So we're looking for an intersection. We're looking for the point where they cross. We're looking for where the x's and y values are the same. Now, the x and y value are not going to have the same value, but here, the x's are given once for any equation for y across the board. So really, we're looking for what x are the y values of these same. -1, and the y value is -4. So what that's telling us is the point -1, -4 is the point that the two equations cross, is the point that makes both equations true. So if we took this here, this point, to just verify that this is true, I'm going to start with this equation here. What that's telling us is that y is -4 when the x value is -1. And we're wanting to verify, we're wanting to show that it's true. And it's very tempting to want to use our properties of equality, being able to add or subtract, do stuff to both sides. But if we look at the right-hand side, well, -1 minus 3 is -4. Well, -4 is indeed equal to -4. It does give us a true statement. If we look at the first equation, y equals 2x squared plus 5x minus 1. So our y value is told to us to be -4. Our x value is -1. So what we're wanting to verify and show is that the right-hand side will give us -4. Well, -1 squared is going to be 1. 5 times -1 is -5, minus 1. 2 times 1 is 2. -5 minus 1 is -6. And 2 minus 6 is indeed -4. So the point -1, -4 is the point of intersection, and it's the point that makes both equations true. Yes, sir. Yes. So all this here that we just wrote down was more just checking and verifying that this is the point of intersection. Questions on this here? Let's look at the next one. Y equals x squared plus 4x minus 4, and y equals 2x minus 5. Well, again, we can grab the graphing calculator and hit y equals. Go on and type that, both of those equations into the calculator. So we can hit clear. X squared plus 4x minus 4. Our other equation is 2x minus 5. Once we get them finished, we finish getting them typed in, what are we going to hit? Graph. And we can do second graph, but graph, it does show us this here. And second graph gives us the table. And again, we're looking for what value of x where the y values are the same. Because if we were solving, we're looking for what value of x makes the y value be 0. Here, we're not wanting 0. We want these two equations, the one in blue and the one in red, to have the same value of y. And that value is, well, the y value would be -7, but the x value is what? What's our point? It would be -1, -7. That's our point of intersection. And that's it.
London back, please come to the office. London back, please come to the office.
All that's telling us is at that point, the two graphs cross, the two graphs intersect. That's our solution. Questions on this here? Now we can check it if we want, but that is it. That's all we have to do. We're ready for the next one. Y equals -x plus 6, and y equals -2x squared minus x plus 3. So go on and type it in. Negative x plus 6 and negative 2x squared minus x plus 3. Give you a minute there to get it typed in. And once we get it typed in, what can we do next? Second graph. And at this point here, we're looking for where the x and what value of x, really where the y values are the same. We're looking for where the y's have the same value. All right. It doesn't look like there is one, so let's hit graph and have it graph it for us. No solution. We can see here they do not cross, they do not intersect. Now it might look like they could if we extend that x-axis to the right, continue positively, but that quadratic is going to decrease faster than that line ever will. So it will never approach, it will never cross. So all that's telling us for this here is that this is no solution because there is no intersection of the two graphs. Questions on this here? Let's look at one more of these. Y equals 3x minus 15 and y equals 1/2 x squared minus 2x minus 7. And again, we're solving these by graphing. So we can grab the graphing calculator, hit y equals. First one, 3x minus 15. Now the second one, we have 1/2 x squared minus 2x plus 7, or minus 7. If we want to type a fraction into the calculator, it is alpha, y equals enter. So alpha, y equals enter. When we say 1/2 x squared minus 2x minus 7. Questions on how we type that in or how we get that typed in? And once we get this typed in, we can go on and hit graph. Now this one's a little different from the ones we've had before, because if we look at this graph, it intersects the graph at how many points? 2. Okay, so we should be looking at 2 solutions. And if we notice on the x-axis, both of those solutions have an x value that is positive, because it's on the positive side of the x-axis. So when we look at the table, well, we are able to see one of the 2 points of intersection is the point 2, -9. So that will be one of our solutions. So we need to look for a second one, and we said that the other solution was also positive. And the other solution is 8, 9. So this here we have 2 solutions. Both of these work. Both of these do give us true solutions, true statements of this here. Questions on this so far? Because even if we wanted to check this, because we've checked one before, because we can look at y equals 3x minus 15, because we could say -9 is equal to 3 times 2 minus 15. Well, 3 times 2 is 6. 6 minus 15 is -9, showing that this is indeed true. And we can use the -9 equals 1/2 times 2 squared minus 2 times 2 minus 7. Well, our 2 squared is 4. -2 times 2 is -4 minus 7. Half of 4 is 2. -4 minus 7 is -11. Showing us that indeed -9 is equal to -9. It shows that this is a point on the graph, that those 2 have the same value at that spot. we can use 9/8. So we can say 9 is equal to 1/2 of 8 squared minus 2 times 8 minus 7. We can start off with 8 squared, which is 64. Negative 2 times 8 is negative 16 minus 7. Half of 64 is 32. Negative 16 minus 7 is negative 23, which does tell us that 9 is equal to 9. In our other equation, 9 is equal to 3 times 8 minus 15. 3 times 8 is 16. 8 and 8 is 16, 24. Way too big. And 24 minus 15 is, lo and behold, 9. Yes. Questions on how we solve these by graphing? All right. Let's move on to the second way to solve systems of nonlinear equations, and that's by substitution. Now, when we solve a system by substitution, we want to get one of the two variables by themselves. Well, luckily for us, most every single one of these here, and especially on the homework, will have y equals. Y will be by itself in at least one of the two equations. And all we have to do to solve this by substitution is take whichever y is by itself. So here, it says y is equal to negative 2x plus 3. And we're going to take that 2x plus 3 and substitute it into the other value of y. Now, what that will tell us is that this y is now negative 2x plus 3. So we'll have negative 2x plus 3 is equal to our x squared plus x minus 1. We plug that value of y in. Now at this point here, we want to get this equation equal to 0, and then we can solve. Now to get this equation equal to 0, first thing we can do is add 2x to both sides. Because here our negative 2x plus 2x will be 0, telling us 3 is equal to x squared. X plus 2x is 3x minus 1. Still not equal to 0, so the next thing we can do is subtract 3 from both sides, telling us 0 is equal to x squared plus 3x minus 4. Questions on how we got this equal to 0. Now at this point here, we just need to solve this quadratic equation. There's different ways we can solve it, because chapter 3 has shown us several different ways to solve quadratic equations. What we'll do for this here, the method we'll use to solve this here, is factoring. So we're going to factor these two, or this quadratic equation, into two sets of parentheses with 3 spaces. Since there is no greatest common factor, we don't have to factor anything out. And since the third term is negative, our signs are opposite. And we look at the factors of the first and third term. The only factors of x squared are x and x. Now our factors of 4 are 1 and 4, or 2 and 2. Which one do we want to try first? 1 and 4. Which one? 4 goes first. 1 goes second. Now we can check and make sure that this is the correct factors, and they are. Because our x times negative 1 would be negative x. And our positive 4 times x would be plus 4x, giving us a positive 3x, which is indeed the middle term that we wanted. So at this point here, we do have two things that multiply together equal 0. One of these must be 0. Either x plus 4 is equal to 0, or x minus 1 is equal to 0. Here we'll subtract 4 from both sides, telling us that one of our x values is -4. The other, we add 1 to both sides, telling us x is equal to 1. Questions on this so far? Now at this point here, we do have 2 points for our solutions. Because -4, comma, and 1. Because we have these two as our x values, but we do not have the y value. Now to find the y value, all we need to do is plug it in. Now we could pick, I'll pick the second equation.
May I have your attention, please? Any senior who did not pick up their banner Friday night after the football game, they need to come by the office between classes and pick theirs up. Thank you.
We'll plug the first x value, -4, in. Because we have y equals -2 times -4 plus 3. Well, -2 times -4 is going to be 8. And 8 plus 3 is 11. So it's telling us that one of the solutions for this here should be -4, 11. We can do the same thing with our other value of x, which is 1. Because we can say -2 times 1 is -2. And -2 plus 3 is 1. So -4, 11 and 1, 1 are our 2 solutions. They're the 2 values of x that will make this work. So -4, 11, 1, 1 are our 2 points that work for this here. Now we didn't necessarily have to pick the bottom equation. We could have gone with the top equation. So we could have said -4 squared plus -4 minus 1. Well, -4 squared is 16. Or plus -4 minus 1. Well, 16 minus 4 is 12. And 12 minus 1 is, lo and behold, also 11. That will give us the same value of y. Because at that point, they intersect, they cross, they have the same value for x and y. We could do the same thing with 1. We could say 1 squared plus 1 minus 1. Well, 1 squared is 1. We have plus 1 minus 1. Well, our 1 minus 1 is 0, telling us y is indeed 1. So it doesn't matter which equation we use to find the y value. We just got to pick one. Might be a little bit easier to use the line. Less calculations we have to do. Questions on this here?
I'll look down for about 2 minutes and I'll look back at this.
We're ready to try another one. Because some of these are not going to be as involved as others. Because here we have y equals x squared plus 4x. In our other equation, y equals -4. Well, with substitution, one of the main things we're going to do is substitute this -4 in for y. So as we're solving, it'll tell us that -4 is equal to x squared plus 4x. Now, for us to be able to solve, we need to add 4 to both sides. Because again, our goal is to get this equal to 0, which will tell us that 0 is equal to x squared plus 4x plus 4. And we're going to go on and continue to factor. No greatest common factor. Since the third term is positive, the signs are the same and they match the sign of the middle term. So plus and plus. Only factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. 2 and 2. And this here will indeed be the correct factors. And since we have two things that multiply together to equal 0, one of these has to be 0. We'll start with the equation on the left first. To get x by itself, we would subtract 2 from both sides, telling us that our x value is -2. With the one on the right, we will, well, again, subtract -2, telling us x is, well, -2. Questions on this here? Well, we do have two values, but they are the same. So how many solutions do we have for this quadratic equation? One. Technically two, but really one. They're just the same value, yes? Now we need to find the y value for this point, yes? Anybody have a guess at what that value is? It's -4. That seems odd that we can jump to that conclusion, but let's look at the two equations. The first one says that y equals x squared plus 4x, yes? The second equation says what? Y equals, what's the only value of y we can have in that second equation? -4. It's the only value that second one has. Y equals -4, only one we have. So the value of y that has to be shared is -4, telling us that the solution is just the point -2, -4. Now we can verify that. We can, as if that seems weird, well, I can still plug -2 back into the one equation that does have x. I can't plug it into the second one because y equals -4 does not have an x, but the first one does. Now our -2 squared, -2 times -2 is 4. 4 times -2 is -8. 4 minus 8 is indeed -4. So the one point that works is -2, -4. Questions on this here? Interestingly enough, if we did graph this, well, this is the wrong graph, as I'm realizing that after I draw that, because it would be over here in the second quadrant, down here, and this here would be the point. Look something like this here. Probably not to scale, but it would be in the lower third quadrant with our line hitting the top of it. Or actually, it might be going the other way. I'm trying to draw this. All right, third time's the charm. Because here would be our y equals -4, our point. Yep, there we go. That's what the graph should look like. All right, questions on this here? We're ready to look at the next one. Y equals x squared plus 9. Y equals 9. Well, this is kind of nice because we know that the y value is 9. And again, we can substitute the 9 into y. Telling us 9 is equal to x squared plus 9. Now we just need to get this equation equal to what? 0. And to do that, well, we can subtract 9 from both sides because 9 minus 9 is 0 equals. So the x squared, and over here 9 minus 9 is 0. 0 equals x squared, yes? Do we have a middle term? Do we have x to the first? So we can use one of our solving methods, which was the square root method. Our square root method said if we get the term being squared by itself, we can then take square to both sides. Now the square root of x squared, well, the square root and square will cancel. giving me x by itself. And whenever we take the square root of both sides, we have to put the plus or minus. And what's the square root of 0? We get this here. Now, is there such thing as positive or negative 0? No. Might as well cross that out, because 0 is just 0. It's not positive, it's not negative, it's not even, it's not odd. It is just 0. Oh, that means we only have how many values of x? And our solution is going to be the point 0, 9. And that would be the graph if we drew it, or graphed it. Questions on this so far? Questions on anything we've done so far? Not too bad? All right. Yes. I believe we have one more with substitution. Now we just really are setting these two equal to each other. So we're saying that negative 5x is equal to x squared minus 3x minus 3. To get it equal to 0, we'd add 5x to both sides, telling us 0 is equal to x squared plus 2x minus 3. You know what? Okay. X squared plus 2x minus 3. This is the equation we have, yes? Let's try graphing it. Now this time we don't have two equations, we have one, and we're trying to find out what values of x will make the equation equal what? 0, yes? So second graph. So now we're trying to find out the values of x that will make the function equal 0. Well, one of them is 1, and the other is negative 3. Because when x is equal to negative 3, the y value is 0. When x is equal to 1, the y value is 0. So it tells us x is equal to negative 3, and x is equal to 1. Yes. Now to find the y value, all we got to do is plug it into one of these two equations. So we can use the top one, y equals negative 5x. Y equals negative 5 times negative 3. So y is equal to 15. So one of our points of intersection is the point negative 3, 15. We can do the same thing with 1. Negative 5 times 1 is, well, lo and behold, negative 5. Questions on this here? Questions on anything we've done so far? We feel good with this here. Okay. We're going to skip that one there. We're going to go to elimination. Elimination. Now to solve a system of equation by elimination, one of the first things I would do is I'm going to rewrite it. And rewriting it is not so much for the quadratic step, the quadratic part of this. It's more for the linear. Because when we rewrite it, we want to line those terms up. Because at this point here, our terms really aren't lined up. Because y equals this second one doesn't have an x squared term. So we're really just lining up the 3x, our x and our constant term. Now the nice thing with elimination with these here, all the ones that we would have, especially on the homework, y is going to be positive. We're wanting to get rid of one of the variables. So what we can do every single time with how these are set up and how they work is just subtract. As y minus y is 0. One of the two variables is now gone. X squared minus, well, we don't have an x squared that's being subtracted from it. We could really add it in as 0x squared. Well, x squared minus 0, x squared is just x squared. Since it's not the one being subtracted, it stays positive. Negative 3x minus negative 3x. Well, this here, the negative is going to make a positive. So negative 3x plus 3x is, well, 0. Negative 2 minus negative 8. Well, the negative is going to make a positive. So negative 2 plus 8 is going to become plus, not 7, plus 6. Questions on this here? Now this one here is kind of nice because we do not have a middle term. We do not have x to the first, so we can use the square root method. Get this x squared term by itself and then square root both sides. So the first thing we can do is subtract 6 from both sides. Telling us x squared is equal to negative 6. Since the x squared term's by itself, we can square root both sides, telling us x is equal to plus or minus. Here, the negative is going to come out of the parentheses, or out of the radical as I, and we cannot take the square root of 6. Yes? So it's telling us that x is equal to plus or minus I squared of 6. Is this a real number? No, so there's a good chance that this here will be no solutions. If we're just solving a quadratic, we do have solutions. They're just not real solutions. All we can do is we can come, I'm going to pull the graphing calculator back up. I'm going to graph this. X squared minus 3x minus 2. Negative 3x minus 8 is, do they intersect? No. So this here is indeed no solution. If it was just a quadratic equation, we do have our imaginary terms. We do have solutions to it. They're just not real. And here, since we're looking for an intersection, the I tells us that there is no intersection. And there's more to it, but that's all we're going to do with this here.